So many of the tests that we're asked to undertake are at different temperatures. So as well as testing materials at room temperature, we can also test materials at up to 350 degrees Celsius and down to minus 70 degrees Celsius. This is an example of one of our thermal chambers that surrounds the complete test space. So the specimen, the grips, the fixture and any other instrumentation is all taken to the test temperature, stabilised before the test is started. This is one of our electromechanical testing machines. This machine has a capacity of 100 kilonewtons in tension and compression. And we have our load cell here, and the pull rods are installed to transfer the force through the pull rod and into the chamber to undertake the test. Understanding fracture energy release rate and how much energy is absorbed through impact is an important part of working with composites, and that can be done statically, very slowly, or it can be done at a dynamic rate as well. What we're looking at here is our Sharpie impact tester, which is a pendulum testing machine. So the sample is installed in the test machine here. The pendulum is raised up to its test height. When the test is ready to start, it is released. It strikes the specimen, which snaps it in two, and we are measuring the residual energy that is left in the striker, and then we can understand how much energy is absorbed in the material. So here we have a composite crush specimen. This has been cut from a flat plate of material here at Engenuity on a water-cooled diamond saw. We've cut a rectangle of material, and then we have applied a crenellation to the end, where you can see here where we have made a series of saw cuts in the end of the material. And the reason this is done is so we can ensure that the specimen fails from this end of the specimen. So this is a damage initiation in the crush front. The next thing that happens is this sample is put into the test fixture. And this fixture we have here is the Engenuity crush fixture in our drop tower. This is our high energy drop tower, and we can range between a 0 drop height all the way up to 1 meter, and the last 300 millimeters is spring assisted. So we have an additional 10 kilonewtons of spring compression that can be added to accelerate the mass downwards. The specimen then goes into the test fixture with the crenellated end going downwards, and the fixture can be adjusted for the thickness of the specimen. So if we look in here, we can see that the crenellated end of the crush specimen is on the flat part of the base. We use a pusher blade to transfer the force from the load cell into the specimen. The crush specimen will then start to delaminate during the test, because the test is run at a velocity higher than 2 meters a second. The result of the test is we measure the force and displacement during the crush event, and we measure the amount of energy that is required to crush the coupon. So we're seeing delamination, and this is the result of energy absorption during the testing. So the output of this test is a crush stress, which is input into our C-zone analysis and used in the analysis for energy absorption for crash worthiness, which is used by many Formula One teams and is used in the energy absorption analysis, such as Sidepole and front and rear crash structures in many automotive applications.
So Miles, thanks for the insights in the factory for the laboratory. Let's talk about sustainability. Now, I've discovered Engenuity is here in Burgess Hill on a X-farm, and obviously we as composites experts, we are very sustainable in all we do. What's the relation of ingenuity and sustainability? What services do you render that fosters sustainability?
Yeah, that's right. So sustainability is a really important subject in engineering, through climate change, and just looking after the planet we live on. So I think everyone has a duty to try and see what we can do to make sure that everything we do is more sustainable than it has been previously. And in the industry that we're in, that's no different. So, so in materials testing, we're looking at the different types of materials that can go into these designs, such as cars and all sorts of other structures, bicycles, road transport and rail transport and all other types, to see what types of materials we can make that are more sustainable and more eco-friendly than they are at the moment. The really interesting projects we've been working on over the past few years, one of them has been using flax composites, which is combining a natural fibre that's grown. So grown in fields like we have at the moment. The fibres are grown from the ground. They're then woven into a mat or a fleece, and then they're impregnated with some matrix to make it into the fibre reinforced composite. And the reason that Engenuity has been involved in that is because this material is being used in a structural application. So we've been involved in the materials testing, the analysis, and the material card development to make this into a usable material as an engineered material.
I asked you to carry this rim outside here, this beautiful nature. Community, of course, if you imagine, I don't know, is this a 20-inch wheel or even 22, I can't say it on top of my head, but it says, of course, analysis by Engenuity. But it wasn't a problem for you to carry this out because obviously it's a lightweight product here. Anything you want to add on this rim here?
Yeah, absolutely. So this has been in our office for a few years, and actually I quite like to see it because it reminds us that Engenuity isn't only composites. This could be a composite wheel, but actually this is a metal alloy wheel. It could be aluminium, could be magnesium, it could be another type of metal. But Engenuity actually comes from a history of longer than 30 years, where we started analysing metals, and then quite quickly we moved on to composites as well. So one of our main areas of interest and one of our main areas of experience is metals analysis as well. So wheels is a big part of that. We also have lots of projects that we work for in the medical sector and marine and other metals sector as well. And more recently we've been doing some projects with large goods vehicles, so where we work in quarries, mining and areas like that. These are all areas of engineering that composites may not fit just quite as easily, whereas big, heavy steel may be the best solution. But then we run into problems with fatigue and other areas like that. So metals is the note I would finish on with this.